Welcome back to our Database Design and Development unit. In this lesson we are going to look at queries or querying the database and retrieving information from the database. We are going to look at the use of select statements, and we are going to look at how to create SQL statements to query our database and retrieve information. As always, we have learning intentions, which today are to learn the purpose and features of SQL, learn how to create SQL statements to issue instructions to a database, and learn how to create SQL queries to retrieve data from a database. Our success criteria for today is as follows: be able to describe what SQL is and its purpose, be able to describe what an SQL statement is and an SQL query is, be able to describe and implement SQL queries using command words such as select, from and where. We will also use logical and arithmetic operators within our where commands, and we will be able to sort data using the order by command. And finally, we will be able to extract information from more than one table using key fields which match across the tables and the use of Equijoins. As always, our success criteria should be referred to throughout the lesson, and this will help you judge your progress. To start, let's look at a couple of definitions. SQL, structured query language, the standard programming language for communicating with databases. Query, SQL statements used to retrieve data from a database. Before we move into SQL queries, let's look at a basic introduction. Structured query language, also known as SQL or Sql, is a standard programming language used to communicate and manipulate the information contained within databases. SQL commands are combined together to form statements. These statements are used to instruct a database to perform different tasks. SQL statements which retrieve data from a database to display it so that we can see the information are known as queries. Let's look at our select statement. They're used to select data within a database. All the data returned by a select statement is stored in a results table like shown in our example here. The database will present that results table to the user when the statement is executed within the database. Let's now build a select statement. In order to build a select statement to display all of the records and fields from a table, the user would create a query using two commands. The select command, which will show the fields or entity attributes we want to see, and the from command, which will detail the tables or the entities that will contain those fields or entity attributes. In this case, our database has two tables, the author table and the book table. If we want to display all of the information contained within the author table, we would have a query like so: select asterisk. Now the asterisk or the wildcard means any or all fields. We will then use the select the fields from the author table. So we're using the select command asterisk, which tells us the entity attributes or the fields, and the from tells us the entities that contain those fields or entity attributes. In this case, it's the author table. So we want to display all of the information from the author table. Please note that SQL statements always end with a semicolon. When we run this query, the following results are shown. Note, this is all the records and the entity attributes from the author table. We have the author reference number, the first name, surname, nationality, date of birth and website for the author. All of the information contained there. Let's look at another example of a select statement. In this case, the user can restrict the data returned from each record by specifying the fields or the entity attributes to select. In this case, we are going to select first name and surname. These are the two fields or entity attributes that the user wants to see. Like the last example, we will use the from command to select the tables that contain those two pieces of information, which in this case is the author table. One or more fields may be selected, but they must be separated by a comma. In this case, this statement would return the following output: the first name and surname from all of the authors from the author table. Okay, let's move on in building our statements. Let's now add in a where command or a where clause. This is used to search for specific records within the database. Where specifies something that must be true for the query to return a result. In other words, where a condition is met. In this example, we have our select command with our wildcard, which means select all. From command, we're selecting the author table, so we want to select all of the records from the author table. Where first name equals Gareth. Our condition is first name equals Gareth. So in this case, we will see all of the authors from the author table whose first name is Gareth. The equals operator is used within the condition to check that the first name field contains Gareth. In this case, this will return one record. All records from the author table where the first name is Gareth. In this case, we have Gareth Owen. Let's look at another example where we can restrict that information even further. In this case, we will select the first name and surname. We will restrict our fields or entity attributes down to those two, first name and surname. Again, we will select those from the author table using our from command. And again, we will insert a condition here using the where clause. And this time our condition will be nationality equals British, where nationality equals British. First name and surname have been selected along with our condition or search criteria, British. In this case, we have returned the first names and surnames of all authors whose nationality is British. Notice that the nationality field is not shown within the result. The nationality field is only used within the condition of the where clause. Let's look at another example where we use logical operators within a complex query. In this case, we will use the AND operator. And this means that we will have two conditions within our where clause, and both conditions must be true. In our example, we will look for the first name and surname of authors where nationality is British and first name equals Nick. So the nationality must contain British and the first name must contain Nick in order to return a result. In this case, we return two records, Nick Hornby and Nick Hunter. We have returned all the first names and surnames from records where the nationality of the author is British and the first name is Nick. This is a complex query. We now have another example using a different logical operator. In this case, we are using the OR logical operator. Again, we will have two conditions contained within our where clause. Only this time, one condition must be true. So either the first condition or the second condition must be true in order to return results. In this example, we will select again the first name and surname from our author table where our author's nationality is British or their nationality is Canadian. So where nationality equals British or nationality equals Canadian. The following results are returned. All the first names and surnames from records where the nationality of the author is British or the nationality of the author is Canadian. Let's now look at a query using our last logical operator. This last logical operator allows us to exclude data from queries. We use the NOT operator to exclude data from a query. This means that the condition must not be true. In this example, we will select the first name and nationality from the author table where not nationality is equals British. The not comes before the condition in this case. This statement will return the following results. We have three records, Eric, Kenneth and Patricia, whose nationalities are American and Canadian, and in this case not British. So our result shows all the first names and nationalities from the records where the nationality is not British. Let's now look at the use of arithmetic operators within our conditions. We have looked at our where clause and the use of conditions in our SQL statements. We will now look at the use of arithmetic operators to compare numerical data. This includes dates and times. The arithmetic operators we will look at are the less than or before when it comes to date and time, the greater than or after when it comes to date and time, the less than or equal to or on or before when it comes to date and time, and the greater than or equal to, which is the on or after when it comes to date and time. In this example, the greater than operator has been used to ensure that the author ref field is greater than 2000. So in this case, we will select the surname and the author ref from the author table where the field author ref is greater than 2000. This statement will return the following output: the surnames and author references from the records where the author ref is greater than 2000. Notice we can see that all the author ref numbers are greater than 2000 in this example. It's now time to continue to build our SQL statements by adding another command. In this case, we're going to add the order by command, which allows us to sort fields or entity attributes. We can order fields in ascending order or order by descending. In this example, we will select the surname and author reference from the author table where the author reference is greater than 2000, and we will order by surname in ascending order. ASC is placed after the field name in the order by statement. ASC stands for ascending. This SQL statement will return the following results. Again, we have selected the surname and author ref entity attributes. Those are selected from our author table. You will notice that our author reference are all greater than 2000. And this time we have sorted that data into ascending order on the field surname. You can see that our surname field has been sorted in ascending order. Just like in our conditions, we also have complex sorts where we do more than one sort. In this example, we will select the nationality, the surname and the author ref from the author table where the author ref is greater than 2000, and this time we will order by nationality in descending order and surname in ascending order. In this case we have multiple sorts. Each of those sorts must be separated by a comma. Nationality descending, comma, surname ascending. This SQL statement will return the following results. Notice that our nationality is sorted in descending order and our surname in ascending order. With a complex sort, the order that the fields are listed within the order by command dictates how the sort will be executed. In this example, the nationality descending part is the primary sort. The surname ascending is the secondary sort. So the primary sort will sort all of the records descending on nationality. We have Canadian, then British, then American. The secondary sort cannot affect the primary sort. Instead, it will sort any repeating values in ascending order on the surname. In this case, we have multiple authors who are British. The repeat value of British is then sorted in ascending order of surname. In other words, we take all the British authors and we sort them in ascending order of surname. Let's now again look at key fields. In this case, particularly primary keys. We discussed these within the design stage of our database design and development lessons. Each table has a primary key field, which uniquely identifies each record within the table. For the author table, we have the author ref as the primary key, and that acts as a unique identifier for each author. No two authors have the same author reference. Within the book table, we have the title as the primary key here, as no two books have the same title. By searching primary key fields, the user can find specific records. For example, by searching author ref for 3197 would return this specific author. This makes it possible to find this author easily, even if there were another Joanne Rowling in the table. Foreign keys are what allows us to link tables. They are used to match entries from one table to another. In this example, the book table contains a copy of the primary key from the author table. It's placed into the book table as a foreign key. If you can't remember this, go back and look at the entity relationship diagrams within the design stage. The foreign key allows the database to link each author record to the appropriate book record. It links both tables. Here we can see that the matching keys show that Nick Hornby wrote the book about a boy. The author refs from both tables match, detailing the author and the book. So up until now, our queries have selected information from one table, and that would be the author table. Let's look now at selecting multiple pieces of information across more than one table. We can do this by matching the primary and foreign key as described in the last couple of slides. We match the primary and foreign key values in the where clause, and this allows us to search for related information from multiple tables. This is known as an Equijoin. An Equijoin, for example, could be used to identify the name of the author of each book. Now, from an example, we will select the first name and surname from the author table and the title from the book table. So we will select first name, surname and title from author, comma, book, where author.ref, which is the primary key from the author table, equals book.authorref. which is the foreign key within the book table. So both of these are being compared. Where a match is found and that they're the same, then the name, the author and title of the book will be returned. Notice that the table names have been attached to the field names using a dot. This allows our database to distinguish which author ref the query is referring to. Our SQL statement, including our Equijoin, would return the following results: our first name, surname of the author, and the title of the book they wrote. That brings us to the end of today's lesson on database design and development implementation. Today we looked specifically at SQL queries and specifically select queries. Thank you for joining us on our YouTube channel, Greif High Business and Computing Science. Please tell your friends about us and don't forget to subscribe. Please hang on though, because we have some extra slides at the end of this video where we are just going to do a recap on some of the database areas that we've looked at thus far. Let's quickly look at this glossary of terms. An Equijoin, a statement used to join tables together within a database. A query, an SQL statement or statements used to retrieve data from the database. SQL, structured query language, so the standard programming language for communicating with databases. A statement, a combination of commands used to instruct a database to perform a task or function. And a wildcard, a character used to substitute one or more characters in a string. Let's now look at the SQL commands we have learned so far. Select selects fields or entity attributes from a database. The from command specifies a table or an entity to select or delete from. The where command used to extract only those records that fulfill a specific condition. The like command used alongside wildcards to compare a value to a similar value. Order by used to sort results in ascending or descending order. ASC, sort ascending, and it's used with the order by command. DSC, sort descending, used again with the order by command. In Appendix 1, we can see the author entity and the entity attributes and data contained within. When we are working with databases, it's always important to look at the tables and the data contained within those tables and the format which that data takes. In Appendix 2, we see the book table, or the book entity. Again, the same advice would be given for this table. Look at the entity attributes, the names given to those entity attributes, and the data contained within. In Appendix 3, we can see the entity relationship diagram for this database. We have our author entity and our book entity. We have our relationship and our relationship description. When author writes, many books. The many part is the cardinality, which is represented by the crow's feet. We then have our entity attributes surrounding our entities in ovals. We can see our key fields are highlighted. Our primary keys are highlighted by being underlined. In the author table, we have author reference. In the book table, we have title. We also have another primary key within the book table, author reference, which is highlighted with the asterisk. This indicates that this author reference is the foreign key. In Appendix 4, we will look at capitalization in brackets. It's not always necessary to capitalize commands in SQL. However, it is good practice. Capitalization helps readability. Brackets are not always necessary either. When creating simple SQL commands, brackets are optional. So for example, both SQL statements are identical here. However, what should be highlighted is that if there is a space within an entity attribute name, for example, if there was a space between author and ref, the square brackets would be necessary in that case. Appendix 5 sees us discuss wildcards again. There are two different types of wildcards used in Microsoft Access or SQL. The asterisk is used to represent 0, 1 or multiple characters, and the question mark is used to represent a single character. Wildcards are used in conjunction with the command like. So for example, we'll select the first name, the surname from the author table, where surname like H asterisk. This query would return all the authors whose surname begin with the letter H. It's also be noted that we can have multiple characters after that letter H. Appendix 6 looks at date and time fields. When querying date and time fields in Access, they have a specific format. The date must begin and end with a hash symbol. For example, select first name, surname from author, where DOB is before or on hash 01011980 hash semicolon. This query would return all authors who were born on or before the 1st of January 1980. And finally, Appendix 7. This deals with duplicate field names and disambiguation. Multiple tables may share identical field names. This is often the case with primary and foreign key fields. In the case where an SQL statement must refer to identical field names across multiple tables, the user must disambiguate the field names. This is done by placing the table or entity name before the field name using a dot. So for example, select first name, surname from author and book, where author.authorref equals book.authorref. The Equijoin above uses the table.field notation to disambiguate which table and author ref is being referred to.